Hello there, Year 9. This is whole class feedback for 9 Hook, 9 Chappell, 9 Faraday and 9 Geim, taught by Mrs. Cowlin on the Discovering and Developing Drugs question that was set a couple of weeks ago. So here is the task that I set. You've got a table on the left with lots of different antibiotics, the date they were discovered, the date they first became available to patients, and the date that resistance was first seen there. Now, to tackle this task, you will need a calculator. I did remind you at the time that you would need one. You can either use your own calculator, or if you are working on Microsoft, you will have a calculator option in the tools in Office. Now there's 6 questions along here. I'll show you carefully how to do question 1 with the calculations and then go through the others together and show some of the feedback work that I got from other students. So first question, enlarged it a little bit to make it easier to see. We've got calculate how long on average between the discovery of an antibiotic and the appearance of resistance to it. So I've taken out the names because we don't need to know those. I've highlighted, put in the table with the dates, when it's available, when it's resistant. You need to be looking at these 2 columns, the date it's discovered, the date at resistance. I actually need to look at the how long on average between, so that's a gap. So this one was discovered in 1928, first had resistance in 1942. So you need to find the difference by having resistance, take away, discovery. You always have the bigger number minus the smaller number. So you need to work that out for each of these antibiotics. And then obviously the last column, the last one found, hasn't yet had resistance. You wouldn't include that because you're not going to guess. You're going to find the average by adding all the differences and then dividing by 9, because there are 1, 2, 3, 4, 5, 6, 7, 8, 9 antibiotics that have got resistance. This type of average is called the mean. This is maths that you'll do quite a lot in maths and also comes in very handy for science. So each of these, remember, resistance minus discovery, resistance minus discovery. Add them together, divide by 9, that's your answer. You don't just choose one because it does say on average. Other questions. Number 2, big bit of feedback. If you plot a graph, I had lots of graphs sent to me, but please remember to join the points. I know it's a bit tricky if you're doing it in lined paper, but you can still do that. I was very impressed with how well everybody had a go at doing that. Somebody managed to find some sneak square paper from somewhere. Thank you very much, Maths Department, I'm guessing. Now, a trend is a pattern and often uses the words decrease or increase because you're comparing. And in this case, the answer would be as new antibiotics are discovered, so it says you work your way down the table, the time taken for resistance to develop has decreased. So it means there's a smaller gap each time before people start not to be helped by the antibiotics. Remember, the answers here are shown in red. Use other antibiotic data to predict the answer to question 3. Should be available around about 2020. Resistance will only be 5 years later, 2025. Without antibiotics, more people will be seriously ill or die from infections. And yes, infections that are now treated by antibiotics could kill people in the past. Advice to deal with antibiotics: only take them when they're essential, always complete the course, don't give to other people are 3 key things. The link I've added in at the bottom is the slightly annoying antibiotics song that you'll probably have seen on TV, because nobody sent me a video of a song they'd made, which is quite a disappointment, I must be honest. Right, Olivia in 9 Chappell did a lovely calculation here for question 2. You can see she's looking at the date, she's finding the difference, and then she wrote her trend statement, and she actually linked it in to something she'd used in history. So she found the date was the date of World War II in there, and she said after World War II it took longer to discover antibiotics than before. So as we've been looking for longer, it's been harder to find them. I guess the ones that were easier to find were found first. A bit like when you're looking for that last egg on an Easter egg hunt, I guess. Okay, Ellie May in 9 Hook Wrote a lovely bit of advice for people here about antibiotic resistance. I'll make that a little bit larger for you if I can. It's not as clear as I hoped. There we go. Lovely highlighted, well presented work. Isabella Chappelle wrote a blog entry. And finally, Jack in 9 Faraday wrote an acrostic. So he took the first letters of the word resistance. I wrote a sentence to go with each one. Nice imaginative answers to that last question. I appreciate how hard you are all working, and I know that it can't be easy at such a distance, but keep it up. You're doing really well, guys. Thank you very much. Anybody that didn't get very far with this task before and wants to have another go now, please do have a look. You will actually find that some of the help with the first question was also posted on Teams for you. You really do need to get used to the habit of looking there, guys. Thank you very much. Speak to you soon. Goodbye for now.